So we have talked about geometric sequences a little bit on the first day, and now we're going to do what we did for arithmetic sequences, and that is come up with a formula for calculating the terms. Okay, so the general formula. And then we'll talk about geometric series. So it says in the first thing, just write the next two terms of each sequence. Right away, you know that it can't be arithmetic because it's alternating between positive and negative. Okay, so there's no way you can do that with an arithmetic. And so take a look. What are you multiplying 4 by to get negative 20? Well, you're going to multiply by negative 5 and then by negative 5. So keep doing that here. So that's going to be positive 2,500 and then negative 12,500. Okay. Now, what I noticed that right away. If you want to, you can take the second term and divide by the first term. Or the third term and divide by the second term. Or the fourth term and divide by the third term. Okay, so always you can take consecutive terms and the third term divided by the second term, never the second divided by the third. Okay, so you might want to do that here if you can't see right away. But hopefully you see a common denominator there, right? So if you're multiplying, then what's happening here? 20 becomes 10. So that means we're getting smaller. So we're multiplying by something less than 1. So that would be multiplying by a half. And so that's going to make the reduced to 10 over 3, because that would be 20 over 6, which is 10 over 3. 10 over 3 times a half is going to reduce to 5 over 3 times a half is 5 over 6. So then 5 over 12, then 5 over 24. Okay. So a sequence is geometric if the ratio between consecutive terms is a constant. This constant is called the common ratio. So we talked a little bit about that before. And that's what we can do up there, right? You're finding that ratio. In general, okay, what's happening here? So T1, to get our second term, we're taking the first term and multiplying by R. So that's T1R. Then we're multiplying that by R. Well, R times R is R squared. And then we're multiplying that by R. So R squared times R is R cubed. That's your exponent laws, right? And so take a look at how these values relate. So the second term has an R value of 1. The third term has an R value of 2. The first term has an R value of 0. There is no R, right? And so the R exponent on R is 1 less than the term number. So here, this would be T1 R to the 9. And then in general, that would be T1 R to the n minus 1. So that is your general term. Okay? T1 times R to the n minus 1. So if we're starting at T1, that means n is 1. Okay? And again, that formula will be given to you. It's nice if you can memorize it, but it will be given to you. All right, so state the common ratio and the next two terms of this geometric. So you don't even have to think about it if it tells you what kind of sequence it is, right? You know it's going to be a multiplication, or this gives it away as well, common ratio. So so to get R, we can go 150, well actually there's space here, 150, term 2, divided by term 1, and reduce that. Well, the zeros divide out. 3 goes into 15 5 times, into 18 6 times. Or you could go term 3 over term 2. And then 5 goes into that, 25 over 30, which reduces to 5, 6. Okay, so state the common ratio. We've got it. And the next two terms. So 125 times 5, 6. So times 5 over 6. 6 is not going to go into that, right? Because it's 25. And then, so that's going to be 625 over 6. And then multiply by 5, 6 again. Oh, what's 625 times 5? It's 25, 2, 12, 2, 31. 3, 1, 2, 5 over 36. And that's that. Okay. So that's just coming up with the common ratio and finding some terms. Now in the next one, it says state the equation for Tn. So that means it's got to be a formula basically, and there's got to be n's in it. So you want to find, so you might want to state out, just like we did for arithmetic, what's your first term and what's your common ratio. So second term divided by the first term. It tells you it's geometric. If you had to figure out if it was geometric, then you would want to do second term divided by first and then check, is it the same as the third divided by the second? But we know it's geometric, we're told that, so we don't have to do it twice. So then the zeros divide out, 4 goes into that 3 times, and into that 4 times. Okay, so Tn equals the first term times, I'm going to put brackets because the common ratio is a fraction, to the n minus 1. And please, if you have really big writing, you've got to try to make sure this n is small and the exponent is small. Okay? So it doesn't look like multiplying. And that's it. Then for T6, just substitute that in, which is really exponent 5, right? And you can use your calculator. So 1600 bracket 3 divide by 4 close bracket exponent 5. Okay, and then if it's given as it's not actually given as a fraction. You came up with a common ratio that's a fraction. So I guess you could have used 0.75. But we usually ask for reduced fractions. So that would be 6,075 over 16. Now really, term 6, that one you could in your calculator go the first term, like you already have 3 here, right? So then you could just multiply by 3/4 to get the 4th, the 5th, and the 6th. Okay, but we'll probably say determine by using the formula. Okay, so that it's not just entering it in your calculator. Okay, then determine which term. So that means what's n? So now this is your Tn. Okay, your nth term. What's n for that? So we set up our equation. So 492075 over 4096 equals 1600 times 3/4 to the n minus 1. All right, so a couple of things. Based on all the learning that you have, we're just going to work backwards and we're going to basically use trial and error. When you get to Math 30 next fall, once you learn about exponential functions and logarithmic functions, then you'll use work with expressions and equations and learn how to solve them so that you could do it algebraically and graphically. But right now, just want to divide both sides by 1600. You can use your calculator if you want. Actually, yeah, let's use it because then it'll reduce it right away. So here, so if I have 492,075 divided by 4,096, okay, then I want to divide that by 1600. And then math frac, oh, it doesn't do it. Huh. So you actually have to do some work. Nice. Okay, so you could probably do 492,075 and divide by 1600 because the others doesn't divide. And then let's do math frac. Yep. Okay, so then that's going to be our denominator will be 64 times 4,096. Okay. Oh, that's not what I wanted, sorry. 64 times 4,096. Okay, there we go. So 19,683. And then a little bit of trial and error. So basically, this is a reduced fraction. So we want to raise 4 to the something to get this denominator. Okay, 3 to the same something to get this numerator. So you want to look and see, well, actually, see if you could reduce that as well. It's not even. 9. Yeah, so let's try. So 4 to the, I don't know, let's go 4 to the 10. Okay, that's too big, so 4 to the 8. Okay, times 4, 4 to the 9. There you go. So 4 to the 9 is that denominator. Let's check, make sure 3 to the 9 is the numerator, and it is. Okay, so this left side is 3/4 to the 9. Okay, so that means n has to be 10. So basically here, so we know 9 has to equal n minus 1, so n is 10. That's really, from what you've learned so far in math, the only method that you can do, as I said. Well, you could graph. Actually, you've learned how to graph something like this. So you could graph the left side and the right side and see where they intersect. So you have learned that method too. Okay. If you do that, it does say determine, so you'd want to do a little sketch of your graph. Okay. Give you a minute to get caught up there. So the next one, geometric, first term and the sixth term, they're using decimals, so you can use decimals. Determine the common ratio. Okay, so think about it. So you've got 12, that's your first term, second, third, fourth, fifth, sixth. Okay, so we did something like this, well, we talked about arithmetic means, finding the middle values. In this case, we don't have to. We just have to find the common ratio. So because we know the first term, so when you think about our formula for the nth term, so in this case, we know the first term, we know n is 6, and we know the value, so we know n and we know the value of it. And so all that we don't know is r. So we can solve for that. As long as there's just one unknown, right? So 91.125 is your 6th term. Your first term is 12. R we don't know. And n is 6. So 6 minus 1. Okay, and we're trying to figure out what r is. So really, this is 12r to the 5th. Okay, so we want to isolate r, so we're going to divide both sides by 12. So here, 91.125 divided by 12. Okay, so 7.59375. 59375. Okay, so remember the opposite of raising a number to the 5th. Exponent 5 is taking the 5th root. So r will be the 5th root of that value. And there's no plus or minus because it's an odd root. So if this is positive here, then r is going to be positive. If it was 4, then it could be, or 2, then it could be both, either positive or negative. So now, in your calculator, you can go, 5th root, so put the 5, math, xth root, and then that answer, second negative. Okay, it's 1.5. It's a nice number. Now, 5th root is the same as raising the number to the exponent 1 over 5. So let's say, for example, I'm just going to copy this out. So say you had that previous answer, and instead of going in and doing the 5th root, etc., you decided, oh, okay, well, I'm just going to raise it to the exponent 1/5. And you don't even need the fraction, right? 1/5, and you get the same thing. So either one. Okay. So that's all that we had to do. Didn't ask you for what the middle terms or the missing terms were, so you just finish up with 1.5. Take a look at the next one. It says insert 3 geometric means between 6 and 96. So we talked about arithmetic means. Basically, it's just the missing numbers between them. Geometric, it just tells you that you are dealing with a geometric sequence. So this would be, okay, we have 6 and 3 missing in between, and then 96. Okay, so you can consider this to be your first term. So remember how there's sort of two ways, using the formula and then just using patternings. So this is T1, and this would be 2, 3, 4, 5. So then your T5 is T1, so 6 times the common ratio to the 5 minus 1. We know T5 is equal to 96. So that's the equation that we're solving. So it's very similar to the last one. Divide both sides by 6. Okay, so what is that? 16. Okay, now we're going to take the fourth root. So fourth root here, both sides. Thing is, it's an even root, so I need to do plus or minus. So r equals plus or minus 2. So can you have two r values? In this case, you can, right? Because, take a look, if we start with a positive, and if r is negative, then we would have a negative here, then a positive, then a negative, and then a positive. So that would work. Okay, so there's going to be two sets of geometric means. So if we choose the positive, it would be 12 times 2 is 24 times 2 is 48 times 2 is 96. If we use the negative, then it could be negative here. So this could be plus or minus. That's always going to be positive. This could be plus or minus, and that's always going to be positive. Okay. Now, remember with arithmetic means, I called it the green method. Okay, so think about what you're doing here. You're multiplying by r once, twice, 3 times, 4 times. Okay, and so r to the fourth is going to be the same as the ratio of that last term over the first term. With arithmetic, the number of common differences was equal to the subtraction of the two terms, because it was arithmetic, right? The last term minus the first term. For geometric, it's dividing. Okay, so then take a look. That's going to give you 16, which is that equation there. And then r would be plus or minus the fourth root of 16, which is plus or minus 2. Right, so whichever, if you want to use the actual general term formula, or if you want to look at the common ratio. Really, it'll just be, make sure you show some work if it's in the written response portion of the test. Okay. Really, for geometric, you're never going to get, in questions, it's rare that you're going to get a huge number of terms, just because by multiplying, if you're multiplying by a number bigger than 1, it's going to increase really quickly to really big numbers. If it's less than 1, it's going to be a decimal or a fraction. So sometimes you can even check the long way with geometric. So this one here, we've got T3. So let me just put that below. So this is 54 is T3, and then T4, T5, and T6, okay? And we're asked to find T1, so really that's T1, and what R is. So this is very similar to the last couple of questions. Notice how this is calling this T3. So what you could do is change it and just think about, okay, 54, 2 geometric means in between, and basically consider this your first term of your new sequence, okay, to get your common ratio. Or you can use that green method, right, and take a look here, 1, 2, 3. So r cubed is equal to negative 4,558 divided by 54. Okay. So, what is that? Negative 1,458 divided by 54 is negative 27. And cubed root, remember, it's not plus or minus, it is the cubed root of whatever that is, which can be negative. So r is negative 3 in this case. Okay, so then you can go back and, well, if you look at this, if we're multiplying by negative 3 each time, then we would divide by negative 3 here. So that would be negative 18, and divide by negative 3 would be 6. Or you can go, okay, well, T3 is 54. That's equal to T1 times R to the 3 minus 1, which is 2. So 54 equals 9 T1. T1 equals 6. Okay. Somehow you have to show the work, right? So I would want to see this. If you then showed me what you were doing here, I'd be okay with that, or you show this. Okay, so example 6, 3 consecutive terms of a geometric sequence are given there. Determine the value or values of x. So this, we did a similar one for arithmetic. Looking at it, it doesn't look geometric, but x is going to be some value that when we substitute it in, the results are going to be geometric. So if it's geometric, we know that there's common ratio between each of these has to be the same. So that means T2 divided by T1 has to be the same as T3 divided by T2, right? So x plus 9 over x minus 7 is equal to 4x plus 12 over x plus 9. Okay. Now, that's a rational equation. Right, so you want to multiply and get rid of the denominators. Now, it's one fraction on each side, so you could cross multiply or multiply through by lowest common denominator. Right, so those divide out, these divide out. And expand the brackets, so that'll be x squared plus 18x plus 81 equals 4x squared minus 28 plus 12 is minus 16x minus 84. Bring that over. Okay, now, does 3 go into all those? No. So, then you can, if you're not sure, I'm trying to think, what are factors of 165? 3 goes into that one, 33, so that's 5 times 3 times 11 times 3. 11, I don't know, I can't really think right now. Something to add and subtract to, so 55 and 9, no. I don't know. You guys can help me out. So if you know it, you can factor it. I can't think right now. So if you're not sure, I don't think it's irrational. So I can always graph it. And 3, someone 3x squared minus 34x minus 165 and let's go okay, so there. Oops. Intersect. Okay, 15. That helps me. And maybe someone already said that. So. And that would be, so 15 goes into that 11, right? Yeah, so 11, so that's 45, negative 45 plus 11. And then, yep, so there we go. So then x equals 15, or a negative 11 over 3. Okay, so those are your x values. Determine, well, it didn't actually say, so you don't have to go back and actually get the terms. So 15, let's do that though. If we put 15 in there, 15 minus 7 is 8. 15 plus 9 is 24. 60 plus 12 is 72. So our common ratio would be 3. If we have 11 over 3 minus 7, so it's minus 21, is negative 33 over 3, so that's negative 11. And then negative 11 over 3 plus 27 is 16 over 3. And then negative 44 over 3 plus 36 over 3. Is negative 8 over 3. Did I do something wrong again? So I'm multiplying. So negative 11 over 3 minus 7 is 14 over, no, that's why. Negative 11 over 3 minus 21 over 3 is negative 32 over 3. Okay, so you can see in this case your common ratio is multiplying by negative 1/2. So you get two different common ratios. And then a couple of application questions here. So it says a new car that costs $36,000 depreciates by 15% of its current value each year. So not 15% as a constant rate, like not a certain amount, a constant dollar value. This is a percentage of each year's value. And this is pretty common. They say once you drive a car off the lot, it's already worth a lot less than what you purchase it, even though you've only driven it a block. Determine the value of the car after 6 years. So I like to write out the value. So $36,000 is now. Then the next year, so think about if it depreciates, that means you have to subtract 15%. So the easiest way is to then multiply by 0.85. That means it's still worth 85% of what it was. So 36,000 times 85% is 30,600. And that's after year 1. Then multiply again by 0.85. Okay, so you can keep doing that, and we want to know year 6. Okay, now what you need to be careful of here, this is called year 1, but it's term 2. Okay, so when you're getting to year 6, you want to think about, okay, well, we started with 36,000. We multiplied by 0.85, but what exponent goes in there? If we were calling this term 1, term 2, then this would be term 7. Okay? Because now is really like term 0, right? So we really have 7 values now plus each year. So 7 minus 1 is 6. Okay, so if you're using terms, that would be 7 minus 1. But if you just write it out and think about it, I multiplied the original amount by 0.85 once to get the value at year 1. Twice to get the value at year 2. So year 6 will be 6 as the exponent. Okay, so value here. And then just get out your calculator. Sorry. So 36,000 times 0.85 to the exponent 6. And then round to the nearest cent, 2 decimal places, so 13,577.38. All right. So just be careful for the applications, because often the first term is not the first year, right? We start now and then after 1 year, something like that. So same with the next one. A photocopier will only enlarge an image by 10%. That's this particular photocopier. All photocopiers these days will enlarge more than that, but determine how many enlargements it will take for an image to be over twice its original size. So that's basically saying you put a paper in, you enlarge it by 10%, get the results, put it back on the photocopier, enlarge it by 10% again, get that result, put it back in. How many times do you have to do that to get the image to be over twice of its original? So I just call choose some variable to start with. I'm going to choose A for the area, because a photo, like a picture or something like that, the area of it. So that's right now. Okay. Then to enlarge it, we don't multiply it by 0.1. That makes it way smaller. We got to multiply that by 1.1, 110%. So depreciation, we went 100% minus 15 to get 85. Now we're adding. Okay, so that's after the first copy made. Then we take that and we put it back in the photocopier. So we're really taking that previous one and multiplying it by 1.1 again. So that's squared. So that's your second copy. And so now we want to keep going until we get twice the area. Okay, so how do we figure that out? Well, we are starting with, we want to get twice the area. We're starting with the area, and we're multiplying by 1.1. And we want to know, I'm going to call it x. You could call it n, although, again, it doesn't match up. N's normally start with t, n equaling 1 here. So I'm not going to call it n for this question. So do we need to know that original area? Well, no, because we're just wanting to double it. So if we divide both sides by a, the a's go away. So then we get 2 equals 1.1 to the x. Okay, so now you're going to, until you learn some topics in Math 30, you have to use your calculator to estimate here. So you're going to want to go, okay, 1.1, and let's say raised to the exponent 3. Well, that's not 2, right? So then you could keep multiplying by 1.1. So that would be to the exponent 4. That would be to the exponent 5. Or you could just trial and error a new guess, right? That would be to the exponent 6. That would be to the exponent 7, getting close. That would be to the exponent 8. So exponent 7 doesn't quite get you twice as much. We want over twice, and that would be 2.14. So when the exponent here, so when x equals 8, we get, we would have 1.1 to the 8 equals 2.14. Okay, so now in words, what is that? So x here, so when we have an exponent of 1, that's the first copy. When we have the exponent of 2, that's the second copy. So if we have the exponent of 8, we need to do this 8 times. So 8 copies, enlargements, will result in double the size. Okay. So that's it. Okay.